Hello, I'll show a video about one of 300 HP DC motors that we did for a rolling mill machine. We did a major rewinding work for it. That's what this video would be about.
Okay, so this is a continuation of the 300 HP DC motor. We found that the armature had faulty windings, so we went ahead and then continued uh, with the decision of saying that let's rewind the entire rotor windings. So far we have dismantled all the windings that you could see from the slots. They have been removed, and the commutator has been cleaned up. In the sense, commutator is going through. We'll go through some more repair to make sure the segments are very cleaned up. So right now you can see that this rotor has around. Sorry, it has got 37 slots, and then these are the burnt coils. So you see these are the burnt coils.
Diamond shape.
So it's a wave winding. Each slot has got 6 conductors. So the pitch of the coil is 1 to 10, and then the commutator pitch is 1 to 56. The total number of segments that you would see in the commutator is 111. So you could see you could divide by 2, and then which is a wave winding, typical to a wave winding. And you can see the conductors have become brittle. So all the conductors are, you can see the insulation is gone, and that's what is proving that whatever we saw in the rotor behavior, motor behavior, right, wherein it was not taking the load. So most of the conductors you could see here, they are all being thrown there, and then they are all brittle. So our suspicion of rotor damage is almost true. And then the next step is to wait for the conductors, and then we proceed with the armature winding. So the conductor size is
5.1 into 3.45.
3.45. Totally each coil is around each coil is
1 kg. 1 kg 300 grams.
1 kg 300 grams. Totally we need around 50 kgs.
50, near 50.
Approximately 50 kgs of copper.
37 sets, sir.
37 sets.
37 sets.
And each conductors or each slot has got 12 conductors.
From this point on, we had to clean the slots. Once the slots were clear, we insulated the slots with F-gloss insulations, and then we had to get the copper strips as per the original specifications, bend them accordingly to the shape of the slots, the back pitch and the front pitch of the commutators, and then bend them in a proper shape and then have them place them inside the slots of the rotor. Those things, we took an initial load test within our company with the facility that we had. One of the expectations from the client is they want to do a proper testing before the entire machine is dispatched to their unit. So they got in their drivers to our company. They did a small test of 30 amperes with their drive, which you could see that's in the video. At the back of it, we were loading the motor with the pumping machine. So that's what you could see there in the video. At the end of it, we dispatched the machine to the client side, where it was installed and tested to the full load. That's the reading that you're seeing, which has been too close to 300 to 300 to 400 amperes of load was what's tested with. After all this testing, the entire motor was accepted by the client, and they seem to be really happy with the work that we had done for them, and everything seemed to be fine after that. Of course, a week of testing was done basically to measure the parameters of the motor, such as temperature, current, field currents, all those things, to ensure that it's really working fine the way it's expected to. So that's the one of the other work that we are doing. And then thanks for listening to me.